So, so this is the beginning of the layout and build of the 3-inch angle block. So this is the print. So fairly simple, not too complicated, but because it is a very simple build, the quality of the welds needs to be excellent and your fit up needs to be very precise. This is an angle block after all, so this means something. These two faces need to be as close to 90 as possible, and notice that these are also thicker, so the intention here is that these will be machined back to allow a perfect 90-degree face to be formed. With that being said, if you look over here, the detail of this particular weld joint right here, it's telling you that there's going to be a fillet on this side, but on this face is going to be a single bevel on one side to allow penetration. Because we're allowing an 1/8 inch of material on here, this weld is going to be at least 3/16 inch deep, so that when you mill back, you don't want to mill back and completely remove the root and then have a big hole there. So you want to go deeper than that. So with that out of the way, the part here was ground down on one face, and this will be the face on the outside, and of course this will be on the inside right here. So even though these are not on the pieces as they come, you have to prepare that joint. That's what's telling you to do right there. And the rest of the welds are 1/4 inch. Now, even though the bottom is 3/8, we always use the leg length of the smaller piece of metal. So even though this is a 3/8 to 1/4 inch, we're going to use 1/4 inch. Because if you use it set to 3/8, you're going to end up melting away this, and it's going to look terrible. So here's what the setup looks like. Okay, so I like getting a really nice stable base setup when I'm working. I like to take some time, get that all straightened out to make it easy on myself to get my build in order, and it saves a lot of time and a lot of frustration. So I found a metal plate for the base here, and using a square, which everybody needs to have and use regularly and often, I tack welded this large block right here, so it's at 90 degrees here and 90 degrees here. So it gives me a nice work stop. This other block on the back side, also at 90, gives me a very nice 90-degree corner in several directions, so that when I set my pieces up here, a lot of the work has already been done for me. I don't have to fiddle with measuring tools while I'm welding and tacking, which is very frustrating. You shouldn't do. Think this all out ahead before you even get started. So this is the base piece right here, and if you notice, I have these red lines over here, and these are also scribed as well. So this is where the parts are going to go. So when I put it in place here, and I have my gussets, let's put our base plate in place right here. This is what all the parts are going to look like. And I said, oh, well, this is a 1/2 inch in. How am I going to do that? I found a 1/2 inch piece of material right here. So when I slip it in place, I don't have to fumble with measuring or trying to hold things in place with 2 hands where I really need 4. So that is going to take a lot of the agony of putting it together. I can also use this to clamp in place to make sure things don't move anywhere. And I'll repeat the same action on this side so that my gussets are dead square. If I need to, I can throw a little block in here as well to hold everything in the proper orientation as I'm tacking it out. So taking time to set up your workspace is something that everybody should do before they get started, especially small assemblies like this, where when things are off a little bit, it really shows, and you just don't want to do sloppy work, because sloppy work is just, it's the worst thing. So take the time. The lab has plenty of parts like this around. If you just hunt around, you can find them. Don't be lazy. And working at home, that's why I always, when I find pieces like this, I grab them and hold on to them. So I have blocks of aluminum and steel. Also over here, depending on what I'm doing, also large plates of copper. that are great heat sinks and great for when you're working very thin stainless steel as a backup plate so things don't burn through. Okay, so the next step here is I want to start tacking these parts together, and I want to tack using very small tacks so that I don't run the risk of actually pulling these parts out of alignment. You notice there is a clamp right here. It's a little visible out of the frame, but the clamp is going to be holding this upper part tightly against this block, and both blocks are pushed up tightly against this corner so that my edges are all where they need to be. I check everything with my square repeatedly in all three axes so that I can trust this setup to be dead square. So since I like it, I'm going to go ahead and lightly tack my parts together, paying close attention that I do not put my tacks in the areas where I'm going to be placing my gussets. So I want to put my tacks way out here where they're not going to be interfering with when I put my gussets in place. So I have two small tacks in place that are going to hold the upper parts in alignment, and I feel pretty good about that. So next, the gussets will go in place. So one will go right there. There we go. Since these are a saw cut, I'm going to kind of turn them until I find them fitting in the best possible orientation. Now, it's not a killer if they're not dead, dead absolutely straight on the sides here, because that's going to be filled with weld. These are just gussets, so we can kind of make some allowances for that. But I want to line them up on the red line because that gives me my my ½ inch right there, which I do want to preserve. So I'm going to go ahead and hit up here first because that's a little easy, and then we'll go around and do the rest. Here you can see I've got the parts set up in the jig, and I've got two clamps holding my parts in alignment. The reason I'm doing that is because it's such a small thing at a right angle that when I put the tacks in, there's a very strong likelihood it's going to start to close up and it's going to squeeze and go out of shape. So what I want to do is I want to tack these two together and try and get the gusset in there as well. It's going to be tricky because it's very small, but this will keep this from closing up, and then get the second gusset in place as well. So I want to make sure that all my parts are going to stay 90 degrees together, because that's what an angle block is supposed to do. So the trick here is really putting the thought process in to figure out what's going to work. So 30 minutes of thinking and figuring out could save hours when you realize you have to undo everything and cut things apart and redo it again. So put the time in the beginning to think out your process before you do it. You don't want to keep working back, one step forward and two steps back. That's very, very inefficient. So I'm going to do my best to move around and get in there and get my tacks in place, making sure I avoid these red marked areas, because that's where the gussets are going to go. If I put a tack here, I'm not going to put my gusset in place. So here we go. I'm going to use small tacks because I don't want this to pull like crazy. And some porosity up on the top. Don't know why the metal is cleaned, but we'll just have to give it cleaning again, I guess. And right over here. Okay, so it should be enough tacks here to hold this in place from moving. Now I can set up and get the other gusset in place. I turn the block 90 degrees this way so I can back it up against this part, fitting my other gusset in place and clamping it in place. So you see the jig has already saved a lot of work right now, allowing me to get them in by a simple 90-degree turn, and there we go. So now to get the second gusset nailed on. Weird porosity up top there, no idea why. So here is a segment of this video on things that don't go as planned. Oftentimes the videos go all through the whole thing and everything is just perfect, but I thought it would be important to take a look at a case where things aren't perfect. So this happened while tacking it up, and as you can see, this is totally not what we should be getting. It looks pretty bad. So the thing here is, well, why? So not getting any gas out of the torch, I actually went as far as to pull the cover off and do some diagnostic to address the problem and see if the solenoid is actually working. So this is what the machine looks like in the interior if you've never seen a TIG welder before. It's on right now. You can hear it going, and right over here, that is the gas solenoid. And for those of you that don't know, a solenoid is a switch operated by a voltage. In this case, 24 volts goes in here, and the switch opens, letting the gas run through this tube right here. It's a very simple device, and actually with the cover on, you can't hear it, but when I opened it up and triggered it, I could hear a very, very soft click as it opened, so there was gas flow coming through. Well, I thought I'd open this up because some of you, this is something you probably have never seen, but the high frequency generator, which has points in it, actually does something kind of interesting, which you can't see when the cover's on. Right over there. I'll get another view from this side over here. This is what actually generates the high frequency signal. And in some of the older machines, those points can be huge and generate a quite terrifying size spark inside. So you can see by this is exactly why you would not want to have any, say, flammable gases like acetylene or propane leaking in your welding shop. When you hit this, boom, it would be bye-bye. So that is the high frequency generator. It is an open set of points with a live spark. So pretty cool. So I went through all the diagnostics, even checking over here from the manual, checking current at a couple of points. Everything checked out perfectly, so that was not it, which left now going through the non-obvious. So when I initially looked at the hose, everything looked fine. No cracks, nothing, but I actually went so far as to take the handle apart, and right here you can see where the hose has rotted away. In fact, it broke again in another spot right there. And I suspect that failed because in the handle, it probably gets quite hot in this section, close as it is to the head of the torch. And this hose is made out of not the highest quality rubber, and it just basically got fried. So the gas came out, and that was that. So right now, the video on this 3-inch angle block is now on a pause until the replacement parts, which include not just the hose here, but a replacement DINS plug that will allow me to hook up a new hose to the faceplate of the machine. So when that comes in, we will get going. So sometimes things don't go as planned, but there's always opportunities to stop, look what you're doing, and learn how to troubleshoot and do some repairs and keep your machine running healthy. So this machine's been running for 5 years, and you know, it's been flawless. The only thing failed is a cheap, crappy hose. That's it.